Welcome back to part 2. Let's take a look at our data from mass and the acceleration. So we don't have a label here, but this is mass. And it looks like these are values of grams. And this is acceleration in units of meters per second square, or meters per second. This data is doing something much different than the last time. Now we see that as mass increases, the acceleration actually decreases. So we call this type of relationship inversely proportional. The acceleration of an object is inversely proportional to the mass of the object. The definition for inversely proportional is that when the change in one variable causes the opposite change in the other variable. So for example, when mass is doubled, the acceleration would be halved. When the mass is tripled, the acceleration is, we'll call it 1/3. When mass is halved, the acceleration is, this gets a little tricky now, half the mass would mean double the acceleration because they are opposite. Does our data support this? So let's use this data here. I'm going to switch to green. So when the mass is around 2,000, we can see that it's going to be around 1 meter per second square. When the mass is doubled to 4,000, now we can see that it is about half that. So this would be around 0.5. So this is some very consistent looking data that this group produced. Good job, team. And in this graph over here, looking at the relationship just from a mathematical standpoint. So in inversely proportional, you are saying that y equals 1 over x. Whereas in the last time it was y equals x. So, move it down a little bit. Oops. Okay. So, this is x, and this is y. 0, 0. So when x is 1, let's just say that y is, let's just make it, well, y would be 1 over 1. Yeah, so this, okay, so when x is 1, we'll do like this, x and y. So x is 1, y is 1. When x is 2, y is 1/2. So now it's going to be here. When x is 3, y is going to be 1/3. And when y is 4, when x is 4, y would be 1/4. If we continue with this here, if we do x is 0.5, then y would be 1 divided by 0.5, which is 2. So 0.5 here would be up here at 2. And we kind of run out of room here. When x is 0, well, when x is 1/3, if x is 1/3, then y equals 1 over 1/3. Now, let's remember, when we divide by a fraction, we can do the same thing as multiplying by the reciprocal. So that would be y equals 1 times 3 over 1, which would be 3. So 1/3 is going to be up here at 3. And similarly, 1/4 is going to be up here at 4. Like that. this is the shape for graphs that that are inversely proportional. So it's going to go like that, like this here. And we see these types of relationships often in physics. This is just the first one that we've seen in our own studies, where the more the mass, the less the acceleration. Okay, now, what can we say about this? On the bottom, when two variables are inversely proportional, the slope is always, well, does this slope appear to be positive or negative? If you're saying negative, I think that we would agree on that. And it's changing, so it's not a constant slope. It's not a straight line. Does it go through the origin? It blank goes through the origin. We can see that it never goes through the origin. Okay. So I'm going to stop here, and we'll do part 3 for page 3.